Let's go ahead and let's talk about something that should be pretty exciting. So as I'm sure you probably picked up, solving matrices or reducing them down is quite a bit of work. And ultimately it's a little silly because we have tools that can do it more accurately and faster. And as long as we're typing things in, we should be able to get the answer and consistently rely on that answer. Often when we're doing our work, it just takes a simple mistake of you miss a negative sign or you miswrite a number, and then everything else is screwed up. Plus, they take a long time. It's good for you guys to get that experience, but I want to show you how to solve these using a calculator. It's a very important tool, and that's why I've encouraged you guys to get a graphing calculator up to this point in the year. So the first step, all right, after we turn our calculator on, let's go ahead and let's clear everything out if we have things that are on our screen. And we need to get to the option that is going to allow us to edit our matrices. And so we need to press second and then the inverse key. So x negative 1 is the inverse key. So yours is probably blue if you're using one of my newer calculators, but the inverse key is right here on the left, and you'll notice since I pressed the yellow button, I'm going to get the yellow option. It says matrix. Okay, these are all the different matrices that we can put in. You can almost think of it like a library. So you have matrix A or B or C or D, and so you can store a lot of matrices on here. I think it goes up to 10 different matrices, so up to J. I typically just keep one in there at a time, otherwise goofy things can happen. You can misuse a matrix and get the wrong answer. So we're going to go ahead, and if you click enter, it will not really do anything interesting yet. What we have to do is we have to go over to the right, and the second menu here at the top, this tab gives us all the different things we can do mathematically with matrices. You guys probably don't know a lot of these. It would be determinants and transposes and finding the dimension and things like that. But there is going to be some stuff here on this list that is useful. So we'll come back to that math option. We just need to go ahead and go all the way over to the edit option, and we can edit any of these particular matrices. So we're just going to edit A. So good old Abraham here. And it starts off by asking us, hey, how big do you want this thing? All right, and so we are going to need to set the dimensions. The first number tells you how many equations you will be dealing with. So if I set that to be 3, it's going to go 3 tall. And the second number is how long or how many variables it will be. And you do have to count the answer as a variable. So for the problem that we have in our notes, it will be x's and y's and z's in the answer, so I need to say 4 things across. If you switch those up, it will look a little different. It'll be taller and not wider. And so you just go back up to the top and you change those different numbers, so it's pretty easy to edit. Now that we've gotten it the right size, we have to go ahead and take the coefficients out of our equation. So all the x's go in the first column, the y's in the second column, the z's, and so on and so forth. So let's go ahead and let's do that here. So negative 1. And you press enter after you're done. That's a positive 1, 2 for our z value. And notice nothing goes into the box until I press enter. So 1 is hanging out down here in the editor, and it says equation 1, position 4. And until I press enter, nothing actually happens. It's nice that it bumps us down to the next row. So 2, and then 3, and then 1, and then negative 2. Keep in mind, you have a negative, not a minus sign. That will give you an error sometimes if you use the wrong one. And then 5, 4, 2, 4 is our last column. Or excuse me, our last row. Rows and columns are different. So I would go back through and I would just check to make sure that the numbers are in the same order. So 2, 1, 2, 1, 3, 4 looks like it matches for the y's, and then negative 1, 2, and 5. Just a little check can save you a lot of headaches and a lot of grief. So now that we have it entered in, we're going to go ahead and we're going to quit and get out of this editing option. So second mode allows you to quit. I don't know if clear will work. Quit just automatically gets you out of anything. It's the default exit button. And now that we have it stored, our calculator remembers it. We have to go back to the matrix option. Now what we're going to do, notice it says A is a 3 by 4 matrix, 3 equations and 4 columns across. We're going to go ahead and we're going to do some math with this. If you caught on the first time through some familiar terms towards the bottom of this list, good for you. So we could find row echelon form, which is about the halfway point of solving a matrix. But we are going to ultimately use reduced row echelon form, RREF, to find the answer matrix. So we can press enter. It takes it and it plops it back on the home screen, and it's waiting for us to tell it which matrix to use. And so that's where we're going to go back again and press matrix. Okay, and we're going to go down to the matrix that we want. So we could go to B. If we had stuff in B, we could go to D. But we typically are just going to keep things in the A matrix, and if we press enter, it'll tell the calculator, hey, I want to find the answer of this particular matrix, and it's good habit just to put that closing parenthesis to keep it all in there. Now we're going to go ahead and press enter, and this is our final reduced row echelon form. Notice it says x is equal to 2, y is equal to -3, and z is equal to 3, and that's a lot faster than just doing this by hand. And so it takes practice to get used to the steps and going through the menus, just like it took practice to get used to graphing things. And so I'd encourage you guys, as you're working on your problems, type the question in and know the answer that you're headed towards. It's a bit like when you drive a car, you know where you're headed, you know the end destination. And so when you get that answer matrix, just write it off to the side and then start doing the algebra and the work. What you can do kind of along the way is you'll do like 3 or 4 steps. I would type in the step that you're on, and as long as you haven't gotten off path, if you're still on track to get the right answer, the calculator will tell you that that step of your work still points to this answer. And so you can always make sure, am I driving towards the correct answer? Am I driving towards the correct answer? If your answer matrix does not match what you wrote down, then that means there was a mistake somewhere in those recent steps, and you can go back and catch them. Honestly, the worst feeling in the world is to do a whole problem, get to the end, and it doesn't match the answer. And so if you proactively check your work along the way, it will just be better for you, and you'll get these problems right more consistently. So maybe for our notes, we can go ahead and write down the matrix that this system would be written as, just so we have a little bit more practice with that. Don't forget the equal sign is that line. So there's our top equation. There's our middle equation. And there's our bottom equation. Sorry, my handwriting's a little sloppy. Remember, in the calculator, we are doing reduced row echelon form, so that's the RREF. And the answer matrix that we saw here on our calculator, we have x is 2, y is -3, and z is +3. All right, and then interpreting that, it's always kind of nice if we have one solution to write that out as a coordinate. So this would be a ordered triple and not an ordered pair. So 2, -3, +3. Thinking back to some of the definitions that we've had, since we can solve this, this would be considered consistent. This is something that we're going to do with every single problem, is try to label it if we can. It is consistent, it can be solved, and because we have an individual answer, this is independent. It is not dependent on any other variable. So we'll see if we can get that. Sorry for my chicken scratch there. All right, now that we have that written down, let's go ahead and let's try some more problems here on the next page. Okay, question number 17. Hopefully if you are looking at this particular matrix, you are pausing for a second because it should stand out to you. This is the solution matrix. This is already in reduced row echelon form. And I know that because it has a diagonal of 1s and everything else is zeroed out above and below them. So maybe just a little note here that this is the answer. We don't have to put this in our calculator. If we did end up putting it in, it wouldn't really change anything. If we did RREF, it would spit out the same exact matrix. So let's go ahead and let's just write out that solution. The solution is 5, 3, 10, an ordered triple. And just to kind of label and define what terms this would be, this is consistent. It can be solved. And it is independent because it has an individual answer. It's not a system that has an infinite number of solutions. So let's look at 18. 18 is not in reduced row echelon form, so we're going to just go ahead and use our calculator. So if we go ahead and clear out our old stuff, we're going to have to go to second matrix. We're going to go edit this particular one, and it's not as big. It's only 2 equations. It is still 4 variables across, and so we can just keep the 4 in there. We will enter in 5, 1, 2, 5, and then 0. You have to include the zeros, 2, 0, and 3. And once we hit enter, you have to enter in that last spot so that 3 actually goes into that cell, into that location. Now we can quit. We can go back to the matrix option, and please feel free to pause this if you ever need to. Notice that our matrix has now changed size. So we're going to go over to the math option, and we're going to go down to where it gives us the reduced row echelon form. After we have that on our home screen, we'll go back to our matrix library. We'll press enter, so it puts the particular matrix in that we wanted to use. And now that we have A included inside of that command, we're going to press enter. Okay, and notice there are some decimals involved with this. Okay, if your calculator is set in a particular mode, it will give you fractions, and you can write down either of those. Sometimes the worst matrices are the ones where you have fractions all over the place. It's quite common, but we'll go ahead and we'll write this down. And just double checking there, looks good. Notice in your calculator sometimes it will put like double brackets. The inner set of brackets just keeps the top equation together. The inner set of brackets down here keeps the lower equation together. And then the overall brackets are technically the big matrix brackets. Okay, so just kind of a formality of how an older calculator types things out. Now if we go ahead and look at what's happening here, we have 1x plus 0.4 z's equals 0.7. This just says y equals 1.5. That actually is part of an answer. And because we can't really get the equation to just have x equals a number or some other variable all by itself, this is going to be dependent on that extra variable. Sorry that I'm writing really small, but just so you can see the equivalent fractions. All right, this is not something that's impossible. This is consistent. It can be solved. We're not getting something that is like false in our matrix. It's not saying 0 is equal to a number. But this is dependent, and it's dependent on the z variable. That's not something that you have to put, but it is something, hopefully it helps you understand what the word dependent means. Let's try 19. 19 looks like it's pretty close to the answer matrix. This is actually RREF. If we put this into a calculator, it would just spit out the same matrix. But unfortunately, this bottom row, the bottom equation, is saying 0 x's, 0 y's, and 0 z's, so 0 equals 7. And 0 equals 7 is absolutely not true. Okay, and so this would technically be the final RREF format, but we could interpret this system as being inconsistent and impossible to solve. There is no singular solution. So two of the planes might be non-intersecting with each other. I don't know if you really call that parallel or not, but you get the idea. If you look at 20, 20 is a giganto matrix. It has a column for W, X, Y, and Z, and so this would be 4 different variables. And technically, yeah, if you think about the X, Y, Z problems, having 3 variables and being in 3-dimensional space, this is a problem where we're in 4 variables, and you could call it 4-dimensional space, which is a little wonky that you're dealing with something that is that advanced. But yeah, that's what this problem could be thought of as. So this is definitely one that we're going to have to go ahead and type into our calculator. All right, let's go ahead and let's clear this out. And this will be the last one that I do for you. I think the others are pretty manageable, but I'll go ahead and put the answers up on this video so you can check and see if you're getting the same answer. Always look for negatives and always look for mistyped numbers. So here we go. Second matrix. Over to edit. We're going to edit this so that it is 1, 2, 3, 4 equations. That should make it taller. If it doesn't, then you just know you were looking in the wrong direction. And then this goes 1, 2, 3, 4, 5 variables across because the answer counts as a column. And so now it's just the process of typing it in. So 2 and 1, 3 and -2 and -6. Okay? Then 4 and 3, 1 and -1 and -2. And I try to double check some of the numbers as I'm going, so it looks good so far. Then we have a whole row of 1s, except for the final position, which is -5. And then the bottom has a pair of -2s. And again, I'm kind of checking my columns as I'm going. They look good so far. It's a pair of +2s. Okay, again, checking my columns. And then the last number is -10. You have to press enter here to get it to actually submit. And now that we're done entering, let's quit. Let's go back to our matrix options where we can, oops, I pressed enter too soon. That is okay. Where we need to go ahead and grab the RREF option. And then we'll go back here. Notice our matrix is 4 by 5. And so we'll just press enter, close in the parenthesis, and let the calculator do the work. This would be a problem that would take us probably 10 to 15 minutes, and that's at max speed, you know, having practiced and understand kind of the best way to solve a matrix. But it did it in just seconds, okay? That's what calculators are great at, doing math fast. But they only do what you tell it to. And so that's what if you make a mistake, it's going to work with the mistake. So let's go ahead and let's write that down. And you'll notice that I always like to fill in the left half first. I think it's just a little easier because it's all 0s and 1s along the diagonal. If you kind of caught, this will be consistent. It can be solved, and it's actually an independent answer. So -1, +1, -3, -2. It is crazy that such a big problem turned out to be kind of nice numbers. That normally does not happen if you just make up a question. So we'll double check, make sure that we wrote it down correctly, and then we'll go ahead and label this as consistent and independent. The solution, the independent or individual solution, is -1, +1, -3, -2. So it's that ordered quadruple, I suppose. Okay, here are the answers for 21 and 22. So you can check the work, but I'd go at your own pace, and I will label them so you get a little bit more practice with the labels. Hopefully this video helped you a little bit, and if you have any questions, please let me know. But using a calculator to help guide you along the path to getting those answers is a great option, and I'd encourage you guys to learn the steps and get good at the steps and get a graphing calculator because it's a pretty powerful tool. Thanks everybody. Take care, and we'll see you next time.